Okay, so this is the last section. I wanted to only highlight a couple of them because there was quite a few errors here. I just wanted to make sure that we highlight some interesting thinking. This section was about factoring completely, and one of the first issues I found was right here on number 13 where it says r squared minus 7r. This person did a very interesting thing by trying to apply the diamond problem in the area model, and done correctly it might have worked out, but in the end what happened was we ended up with some two binomial factors for r squared minus r, and that really would not have worked to our advantage because we should have, when we multiply these across, r times 7 and 1 times r give you 8r and not the 7 that is negative here. So I do want to highlight this thinking because it's not bad thinking. I think it's a good way of being consistent. So what I tried to do was apply that same thinking here. And I think what the person was expressing was that when you have r squared minus 7r and there's nothing else, then that c term, that last term, is a plus 0 or minus 0, which is fine. And then that means that when we go to set up our diamond problem, though, and again, I don't think this was set up incorrectly on the page, but just to highlight it, r squared times 0 gives me 0 at the top of my diamond problem. And negative 7r, those two numbers on the left and the right have to add to negative 7r. Well, in order to multiply to 0, one of my factors has to be 0, so I'll put that as a 0 there. And since 0 is neither positive nor negative, in order to add to a negative 7r, I have to subtract 7r. So this would be how we set up the diamond problem. It was pretty close. I mean, it looks like they had something very similar. Now, translating this diamond problem to an area model is where we made our mistake, because our first term goes here in the first box of the area model. Then these two split up the area model. So I put my negative 7 there and my plus 0 then in the lower left corner. And then technically, if I were being cautious, I probably should have made this one here plus 0 in red, because that plus 0 comes from the plus 0 of my original expression. And when we look at it this way, it becomes pretty obvious that this bottom row here is pretty irrelevant. So I really don't need that plus 0 plus 0. And you can look at it just like that if you wanted to. You can look at that as what do these two have in common? They both have an r. And when I take that out, I'm left with, when I take that r out, I'm left with r minus 7 times r and a negative 7, because r times r will give me that r squared there. And r times negative 7 will give me that negative 7r there. So that would be our completed factored form. Another issue I saw with that problem was a couple of people turned it around. After they factored out the r, they changed the signs kind of arbitrarily. And I think it comes from when we were doing these and we had to factor out a negative r, because factoring out a negative r would definitely change the sign of my 7 and my r squared. But I wanted to show you why you can't just switch the 7 and the r, specifically when there's a negative in between them. It's because subtraction does not commute. So this was our answer for the last problem. It was r times r minus 7. And when I distribute that r in, I get r times r, which is r squared, and then r times negative 7, which is negative 7r. That tells us, what our original problem was. But if I switched it around almost arbitrarily, then when I multiply it back in, I get r times 7, which is a positive 7r, and r times negative r, which is a negative r squared. And you can see that these two are clearly not the same thing. This was the expression that we originally started with, and this one clearly is not. So don't switch these arbitrarily. You could switch these if you factored out a negative r, But there is no need to factor out a negative r. You can just factor out a positive r and leave it like that. Okay, and for the last part of the things that we should do differently, let's look at this one page and see a couple of issues. On number 14, this is factored, and it's correctly factored, but it's not factored completely. It's not factored completely because that 2x minus 12 still has a common factor. And if you take out the 2, then you'll end up with 2 times the quantity of x minus 6 times the quantity of x minus 8. And this is why I always suggest that we do the steps as I gave them to you, which would be first make sure that they're in descending order, which this one is, x to the second power, first power, 0 power, and then to take out any greatest common factor. Do that first because it'll save you a headache much later. Here, in this case, if we present this as our answer, 2x minus 12 times x plus 8, that would be an incorrect factored form because it's not completely factored. On the other hand, if we take our expression, find that the greatest common factor between 2x squared, 4x, and negative 96 is the number 2, I can factor that out of all 3 terms. Then I have, in parentheses, sorry, there's a little bit of a glare here. In parentheses, I have x squared plus 2x minus 48. And that I can put through the diamond problem in the area model. And in the end, come up with the answer that I had just stated earlier, that it would be 2 times the quantity x minus 6 times the quantity of x plus 8. So those are the real issues that I've found mostly. The only other ones had to do with changing signs, making sure your signs were correct, and not mixing up when you have a perfect square trinomial and a difference of squares. For instance, this one here, number 19, is a difference of squares. The difference of squares always produces conjugates. That's where my factors are the same terms but different signs. So this one should have been 5x minus 3 times 5x plus 3, not 5x minus 3 squared. If I have the same middle terms, then I'll end up with a trinomial, which is like in 21. 21 is a perfect square trinomial, which means that where did 4p come from? That's interesting. Anywho, 21 should have been a perfect square trinomial. So that's one that should have ended up looking more like this. This one, the square root of 9x squared is 3x, and then the square root of 16 is 4. With that middle sign being negative, this one should have been 3x minus 4 quantity squared. So the shape of the answers between these two are mixed up. This one should have been a plus and minus. This one should have been a number squared. But I don't know where 4p comes from. Well, it looks like it comes from up here. Anyway, the last thing I wanted to do is I want to highlight, again, some interesting thinking. Somebody who did things a little bit differently, but did them very well and very correctly. So let's take another look at this person's paper and see their factoring. And I can show you that they did something called factoring by grouping rather than just straight factoring. Here we go. Let's look at this one. This one's the easiest to see. So what this person did was she took a look at her 3 terms and then kind of broke them up like we do with our diamond problem. I didn't see a diamond problem drawn on this page, but that is one way to get these 2 numbers here. 13, that negative 13r, breaks up into negative 5r minus 8r. We do that with our diamond, right? We do that by saying negative 13r, negative 13r breaks up into negative 5r and negative 8r because it multiplies to a positive 40r squared, right? And so after having broken this middle term into two numbers that will add to negative 13, she then groups them. She factors out an r from these two factors here, these two terms here, and she factors out a negative 8, very cleverly factoring out a negative 8 from these two terms here, because by factoring out a negative 8, what she's left with is r minus 5 and r minus 5. And so in doing that, then she can say, well, I have a number times a number minus a number times that same number, right? So that's the same thing as having r minus 8 here times that number. This is how I learned how to factor. It's called factoring by grouping. And to be completely honest, it's exactly the same thing as using the area model. It's just that the area model is much more visual. We would have turned this into a square-ish looking thing that has r squared here plus 40 here. And then we would have taken our minus 5r and minus 8r. And so this is how we group them. Notice that our r squared minus 5r is the same as her group right here. Our r squared, whoa, sorry about the flash there, r squared minus 5, right? And then our negative 8r plus 40 is the same as her second group, which she finds, I lost it, there, r 8r minus 40. So the area model is just another way of accomplishing the same goal of factoring by grouping. Factoring by grouping is what we old folks learned way back in the day. But you guys can now have a much more visual, much more interesting way, I think, of factoring. Anyway, sorry this video was a little bit longer. There was a couple of more things I wanted to talk about, and I did want to highlight that person's interesting thinking. So if you know who you are, pat yourself on the back. You did a great job. Hopefully you guys see this on Sunday because you do have your diagnostic on Monday. Good luck on that. Take care.